I'm going to do two different videos on this objects module, and one will be about 2D objects and one will be about 3D objects. And on 2D objects you have 1D measures and 2D measures. So for example, if I have a rectangle, I have a one-dimensional measure, which is the perimeter, and then I have a 2D measure, which is the area. And we handle these differently if we change the dimensions. So if this is x and this is y, the perimeter is 2 x's and 2 y's. And the area is x, y. You can draw in a grid if, so you would have like y, and you would have x copies of y squares, so x times y. If I were to photocopy this object and make it then twice as big, it would be twice as big in this direction and twice as big in this direction. So the perimeter would be 2 times the new length, which is 2x, plus 2 times the new height, which is 2y. So 4x plus 4y. So ultimately what we did is just multiply the perimeter times 2. The area would be the new length times the new height, and we would have multiplied the old area by 4. So the thing that's happening is, if it's one-dimensional, and I do a proportional change, so I'm changing it all by the same number, multiplying it all by 3, halving it all, so not stretching it, keeping the same shape. In a one-dimensional change, I only multiply by that number once. But in a two-dimensional change, I multiply by it twice, and then we'll see in a three-dimensional change, we multiply by it 3 times. So we multiply by the number of dimensions that we're altering. If I just stretch it, so I just stretch out x, then perimeter has to be reevaluated altogether, and the area only gets multiplied by that number one time. Okay? Okay, so that's rectangles. Let's talk briefly about triangles. You know that if you have a triangle like this, and this is the base and this is the height, then the area is 1/2 base height because it's half of the rectangle. But what if you don't know that? Well, the thing is, it's still 1/2 times base height if you know the height. Not the slant height, the height, the vertical height. Because I can still make a rectangle, and if I pick this one up and stick it to that one, we have 2 copies of the same thing. So it's still half. Also, by the way, a parallelogram has area base times height, whether it's a rectangle or not, if you know the vertical height. So we could just take this and make a copy of this triangle over here and would have a parallelogram. So in either argument, you end up with the same thing. It's just that sometimes we don't know. Having issues with my eraser here, I guess. So the thing is, sometimes you're given the height. Oftentimes you're given the height, actually, in problems, but you'll probably be given this one and that one. So if you're given this one and this one, good. Then just multiply 1/2 times. So if you're told this is 2, this is 4, 1/2 times 4 times 2, 4. If you're not, you might be given this angle and this value. Okay, so if you're given the slant height on one side or the other, so let's say this is given to be 60, but we'll assume these two aren't 60 each. So this one's given to be 60, and you're given all 3 sides, say. So let's say 5, 4, 6. So we can use this and this, so we know now sine is opposite over hypotenuse. So sine of 60 degrees is height over 4. Well, we know that sine of 60 degrees is square root of 3 over 2. If not, we can put it in the calculator. So multiplying by 4. So this is 2 root 3. So now we had the sides in a single angle and we were able to get the height. So 1/2 base times height equals 1/2 times 5 times 2 root 3 equals 5 root 3. Okay, so now we can solve for triangles with much less information than we used to need. Okay. Now let's talk a minute. So we've got triangles, parallelograms, including rectangles, let's talk about other polygons. So I want to talk about this a couple of different ways. Let's suppose that you start with a triangle and you know that that has total measure 180 degrees, and you add a triangle to it, so now you have a quadrilateral. So now you have a total of 180 plus 180 degrees, and I can add another one and get a pentagon, and then I've got another 180 degrees. So what happens is every time I add a single side, I'm basically punching out another triangle. So I keep adding 180. So I add 180 for everyone beyond 3. So if I know the number of sides, then if I subtract 2, that's the total number of triangles. So times 180. Another way to think about it is, if I build the thing out of triangles to start with like this, so I split instead my pentagon into 1, 2, 3, 4, 5 triangles like that, then altogether I have 5 times 180 degrees. But I don't want to count these, but that's 360 degrees. So 5 times 180 minus 2 times 180. See, these are the same. So the way you find out the total sum of all the angles is this way. So if you wanted to know a single angle, then you would just divide, in this case, by 5. If this is a regular polygon, then each of these triangles is identical, and so one of these is half that. So then you can always say, okay, I've got 5 triangles, so let's do 1. Pretend we know nothing but a side length. So let's say that we have a pentagon. I did not draw that regular. Well, obviously I can't draw anything regular, but I didn't make it close. Okay. So we'll say this is a regular pentagon, and we want to know the area. And let's say that this is 6. So each of the side lengths is 6. So what we want to do basically is calculate a single triangle and then multiply it times 5. So the total sum of the angles is 5 minus 2 times 180. 3 times 180 is 540. Okay, so each corner gets 540 degrees divided by 5 is 108 degrees. So each individual triangle that has half of this. Okay, so that's 54 degrees. I want this. I know this. Okay, so in a case like this, we know this, and we know this angle, and we still need the height, okay? So we have adjacent, we want opposite. Tangent, 54 degrees, equals height over 3. So this is 3 tangent 54 degrees. So each individual triangle is 1/2 times 6 times 3 tangent 54 degrees. And we've got 5 of them, so the total so approximately 62 square units. That's not what I want. Okay, it's square units because it's area. The perimeter of this would just be 30 because we have 5 6s. So if we were to make a photocopy of this, say, and let's say we were shrinking it this time, so we shrink it to half. So if I say we're going to shrink it to half its size, you might think that means half its area, but if I do it on a copy machine, it actually shrinks both dimensions by half. So I'm shrinking it by half, which means the perimeter is just going to be half times what it was before. But the area, we're halving both directions, this direction and this one, so that's squared. So 31/2 units squared. Okay, so this is perimeter and area of a polygon, and we've done triangles, we've done parallelograms, circles are a separate mod. So the only thing left to talk about that's two-dimensional is composite figures. So let's say I needed the area of this shape. And let's say this is 4, and let's say that's also 4. Okay? Well, let's make it 3 just so it's obvious what's happening. So the way you do a composite figure is you split it into pieces. So we would go square plus triangle in this case. So the square, 4 times 4, triangle, 1/2 base times height. If this is 4, then this is 4. If this is a square, which is what I'm assuming. And then the height is 3. So again, if you're given the vertical height, you don't have to do any other work for that. Okay? Now you might also see something like this, and then you may be told these are semicircles. So let's say that this is 4 and this is 10. So we would take this plus each of the sides, but these two together make a circle, so let's save ourselves some time. So the rectangle is 10 times 4. Circle is pi r squared, and if this all the way across is 4, then the radius is 2. Okay, so that's the area of that. Normally you wouldn't be given these lines, I guess. So pretend that I hadn't given you that line. So you're given this, and you're told this is 6, and this is 8, and this is 11. So you'd have to see to split it into 3 pieces. This one, so this triangle, we would have to solve. This side is 6. This side we have to solve. But look, if this is 8 and this is 11, then that one's 3. 8, 6, 6. So triangle, 1/2 base, height. Rectangle, base, height, or width times length. 1/2 pi r squared, because it's a semicircle, not a whole circle this time. So 1/2 of pi r squared. The diameter is 6, so the radius is 3. Okay, and so that's the total. And you might have to put that in your calculator to match a decimal, or you might be able to write it this way. It depends on how the question's stated. So I think this fairly wraps up two-dimensional objects. So I'll try to upload this morning and try to write an assessment for this, and then we'll do the three-dimensional objects hopefully this afternoon.